Hey everyone, welcome. Last session of Build. Thank you guys for taking the time to come this afternoon. My name is Liz Threlkeld. I'm a program manager on the Continuum for Phone team. So I'm willing to bet that everyone here actually has probably 2, 3, or more devices on them. You have a laptop, you probably have a tablet, a phone, et cetera, et cetera. I actually recently have started using my phone as my one and only device, and that is because of Continuum for Phone. And I have a Surface here for demo today, but I can assure you in my daily life, I use my phone for 100% of my daily activities. So I'm going to start out with a demo. I'm sure some of you guys have seen some of this if you stopped by our booth or saw my first session. But I want to make sure everyone has the same background on what exactly Continuum is. So Continuum allows you to use your phone like a PC. And you can do this by docking it to any external screen with a Microsoft Display dock or a few other docking options that I'll show you. And you can connect a keyboard and a mouse directly to this dock so that you can be productive as though you were using a PC. So I find the best way to get the point across of what Continuum is by showing it. And I'm going to show you today by connecting my phone to a Microsoft Display dock. To give you guys an idea of what this dock looks like, it's a small little cube. It's literally about 2 inches by 2 inches, maybe 3. And on the back of it, there's an HDMI and a display port, and those two ports are used to connect the dock to an external screen. There's 3 USB ports, which can be used to connect a keyboard, a mouse, and other peripherals. And then there's USB-C for power, and USB-C on the front of the dock for connecting the phone to it. So I'm going to go ahead and switch over to a multi-view display. So here you can see 2 things. I was actually cheating. I was already using my phone for this presentation. So on the left, your left, yes, you can see my phone as I'm using it. And on the right, you can see the output of the Microsoft Display dock that I have it plugged into. And so I'm actually using a really cool multi-screen PowerPoint experience right now. I have this view where I can see the slides, my notes, things like that. And all you guys can really see is the output of the display, except for right now, because I'm showing it to you. So I'm going to go ahead and exit PowerPoint and just give you guys a feel for what Continuum is. So when I get to work in the morning, the first thing I do is go ahead and open OneNote, because I keep a running to-do list of all of my work for the day in OneNote. So I'll launch that. OneNote has some new features today: inking, storytelling. So here's OneNote, and you'll notice that even though this OneNote app is being powered by my phone, it actually looks exactly like it would look if I was running it on my Surface or any other PC. And that's because it's a universal Windows app. And the kicker is that if you build a universal Windows app, you shouldn't have to do a thing to support Continuum. Your app should just work. Now, there's a bunch of nuances with that. I'm sure some of you are doubting that, and I'll talk through some of those nuances throughout the hour. But in general, all you have to do to support Continuum is build a universal Windows app. So while I'm using OneNote on the big screen, I like to be able to multitask. So you'll notice that while I'm running OneNote, powered by my phone on the connected display, I can actually go back to my phone, and I can interact with it and run a second app, just like I would expect to be able to. So I'll launch Mail. That's the other thing I do often as a program manager, is respond to emails. So you can see here that I can actually go to Mail, I can use that, and then at any point in time, I can move back to the keyboard and mouse that I have plugged into my display dock, and I can navigate the external screen instantly and fluidly. And I can always use these 2 displays together simultaneously. So all of you here are developers, and you're probably thinking, great, I can run universal apps, but I have to run Visual Studio to do my job. So we have a couple of solutions for that. Visual Studio is too big and robust to run directly on the phone, so we often use a remote desktop client to use the Win32 apps like Visual Studio. And I'll show you how that looks. So we have a new feature on Windows Mobile today. It's actually getting released very soon, called Azure Remote App. An Azure Remote App allows you to basically take an app, host it in Azure, and access it from your phone, just like you would access any other app on your phone. So if you look at my start screen, right where my finger is, you can actually see that I have Visual Studio 2015 pinned directly to my start screen. Now, this isn't actually, again, running locally on the screen, but it is running in Azure. So I'm going to actually open it on the connected screen, because it's going to be way more awesome than running it on the phone. And when I launch it, you'll notice that the splash screen for the remote desktop client popped up. And that's because it's actually running through the remote desktop client. Here we go. Somebody was messing with the Visual Studio app on my phone. Sorry, guys. But here we have the full Visual Studio 2015 running in Azure. And this is completely powered by my phone. I don't have a PC. I just have a phone powering this PC experience through the Microsoft display dock. So this is great. I can get all of my work done, as I said, with a combination of universal apps and things like Azure Remote App to run Visual Studio. So I just showed a bunch of Microsoft apps. I want to show off a couple of third-party apps, and then we'll get into the details of how you actually think about designing your apps so they work in this experience, and to color up another couple technical limitations that you might run into. So one thing I do all the time is take pictures. My husband and I actually own a farm up in Washington, and we have alpacas and chickens. And people love getting pictures of alpacas and chickens because they're funny-looking animals. So one of my favorite things to do is use Continuum to use the PixArt app to actually edit and send photos to people. So I love the PixArt app. It's a great universal Windows application. And this app allows me to put basic filters and edit photos so I can share them with people. I have some pictures from my farm in Dropbox, and so I'm actually going to go ahead and open up some of these pictures. Here you can see some of my alpacas. They're very weird looking. Let this guy load up. Here we go. Meet Betty White. So I don't want to just send a picture like this. I like to put a little bit of retro things on her. So I'm going to put this retro filter on Betty White. And she'll load up with the retro filter. And then I can feel free to share this picture with anyone, anywhere. So great. She's retro. I can apply that. And if I wanted to share this picture, one option for me would be to go open the messaging app directly on my phone, like I normally do, and send it with touch. But I find that kind of cumbersome when I have a keyboard and mouse. So one thing that I can do that I love is I can actually just go to Start, and I can open the messaging app right here on the big screen. And so here I can actually go ahead, I can type text messages. Hey there, I hope you're at my session. Ooh, I can't spell. And this person will be able to get my text message as though I had sent it from my phone, because I really am still sending it from my phone. So I'll close out of some of these apps. So I know everyone here doesn't like to work all the time. One thing I like to do in the evenings, on the weekends, is actually sit back on my couch and enjoy media apps. And I don't want to have to carry around a keyboard and mouse if I want to watch media on the external screen. So we have built a controller application for Continuum. And this acts as keyboard and mouse for the external screen. So you can see as I'm moving my finger on this trackpad, it's actually moving around. And this is something for you guys to think about as a way that users can interact with your apps. So far, we've only really talked about keyboard and mouse. But the user could also be using this kind of lower level keyboard and mouse through the controller to interact with the apps that you're building. So this works just like a touchpad on a laptop. I can go to Start. I can launch an application. I'll go ahead and launch Hulu, because that's what I watch a lot of videos through. And again, because Hulu is a universal Windows application, it's going to adapt to take advantage of the full size of the connected screen. It will look just like it would look on a desktop if it was running on, say, my Surface. And I'm going to look for a show that I enjoy watching. Oops, sorry, won't pick that up. You'll notice that when I clicked in the search field, a text box popped up, and I can actually use the phone to type directly in this text box and search for the video that I want to watch. I can then use the phone to navigate to that video. I can scroll with 2 fingers, and I can actually go ahead and from here play full screen media on the connected display. So for all you media developers out there, it's totally possible for you to build an experience and have full video playback up on the connected display.
As the doctor walked up the steep
You can see that it's extremely performant. It looks great. This is a full HD output display.
The soldiers at the hospital.
I'll pause this because we don't really need to watch the whole thing. Okay, so the last thing I want to show you guys, just to get your minds going, of the types of apps that you could be building that work with Continuum. I also like to play casual games. I'm not really an extreme gamer, but I do enjoy casual gaming. Let me get my mouse hooked up here. So, sorry guys, I'm having some technical mouse difficulties. Great. No, that didn't help. Okay. Sorry guys, bear with me. I'm on a pre-production build. Oh, it looks like I actually lost video from the AV guys. If you could all help me out, get it back. Perfect. Here we are. Okay, I think I'm back in action. Thank you guys. So, I was saying I'm a casual gamer, and recently a lot of developers, some of you in here probably, have been building games that are actually universal Windows apps. And the app that I'm loading is called Prune, and Prune is a beautiful universal Windows app that involves basically you trying to make a tree grow, and you prune it on the way. And so this app is great because it actually takes advantage of the full screen. And not only that, but even though it was built primarily for touch to be run on a phone, it actually works perfectly with a keyboard and mouse. So here, I can select a level, and I can use my mouse entirely to play this game. So the whole point is to essentially grow trees out of the ground and prune them so that they reach the sun. And so you can see that it's really easy for me to use mouse to do this. And I'm not very good at it, but that's okay. So this is great. So this is just another example of a game that a developer has made that's universal. They had no idea Continuum existed when they built this game. They didn't optimize for it in any way. All they did was build a universal Windows application, and their app just worked on Continuum. Great. So I'm going to go ahead and switch back to PowerPoint on my phone. Perfect. Okay, so let's get grounded in a few configurations that your users might use with Continuum. The primary use case that we are seeing people use this in is a wired dock with a keyboard and mouse attached. This means that people will be using your apps as though they were sitting in front of a PC. And so they'll be interacting with keyboard and mouse. They might have things like external storage or external speakers attached directly to the dock. There's also a wireless docking option. This means that the user can connect wirelessly to any Miracast receiver and power exactly the same experience you just saw through that wireless receiver. There's wireless dongles. These are small little thumb drive size things that the user can plug directly into an HDMI port on their TV. And they can sit back on their couch and they can use the touchpad on the phone, or in some cases, if you build support for it, even the Xbox controller. You can check this out later. I'll show it at the end if we have time. It also has been at the booth. And one thing that I want to point out about wireless configurations is that some Miracast receivers are better than other Miracast receivers. We did a lot of work in the last release to build firmware improvements that really decrease latency in keyboard and mouse. And this becomes super important when users are using your apps to be productive. So we recommend to all users and yourselves for testing purposes that you use the ActionTech ScreenBeam Pro, the ActionTech ScreenBeam Mini, or the Microsoft Wireless Display Adapter. These are the devices we can guarantee have the right firmware to have the best possible experience. And the final hardware configuration is what we call a clamshell, but it's essentially a dumb shell with a screen and a keyboard and a dock inside of it, so that to the user it feels just like a laptop, although it's powered by your phone. HP actually announced the first one of these clamshells just a couple weeks ago at Mobile World Congress, their mobile extender. And this device is the first real laptop dock that we've seen. And the great thing about this is because this laptop dock doesn't have a battery or any CPU or a motherboard, it can be the thinnest, the lightest, and the cheapest laptop form factor on the market by far. So I'm looking forward to this device coming out later this year. Great, so I think everyone has the same background. Let's talk about what it means to develop apps for Continuum. As I said, all you need to do is build a universal Windows application. If you do this, you should have an app that works well on Continuum. Every app that I showed you had no idea that Continuum was a thing or existed when they were building their apps. They just built their app to run nicely across phone and PC, and whenever they tried it on Continuum, it literally just worked. So we aren't lying. You should just be able to build a universal app. So let's talk about what it means to actually build a universal app. There's two things you absolutely have to do to be successful on the universal app platform. You have to build an adaptive app, and you have to target the right set of device families. For example, if you build a universal app that only targets the desktop device family, you actually won't get any experience on Continuum because we only run universal apps that target the mobile or universal device family. And I'll talk more about that in a bit. Things that you should do or should think about doing but aren't really required are things like adding scaling assets if you want your apps to be pixel perfect on any screen. And finally, if you want to do something like PowerPoint, where you actually take advantage of both screens, there's a couple ways you can do that. So when thinking about adaptive apps in the context of Continuum, your users will really be sitting in front of what they think of as two devices, even though they're both powered by a phone. They'll have a phone, and they'll have what they think of as a PC or a TV. And so in that light, your apps, when they're running on the phone, should be optimized for the phone. And when your apps are running on a connected display, you should be thinking about them as either a desktop or a TV, and optimizing your UI according to those interactions. And in reality, again, all standard adaptive techniques for universal Windows apps apply directly to Continuum in the same way that they apply to building an app that runs across phone and desktop. So if you've gone to any talks about building universal apps, all of the same adaptive techniques apply. Only for Continuum's case, the primary display is a phone, and the secondary display, again, is a monitor or a TV. So we build apps today with a thing called responsive design. Responsive design has three main components. The first is adjusting your content density in your app according to screen size. So on a phone, you might want to have lower density content because the user's sitting here and it's a smaller screen. Whereas on a PC, the user is going to be interacting with a mouse, and they're going to have more screen real estate, so it's OK to have a higher density content. You should take advantage of device capabilities. For example, if the device has a microphone or a camera, you can leverage those. In Continuum, the phone has a camera, a GPS, and a microphone, whereas a monitor has none of those things. But even though your app might be running on the monitor, it could still leverage some of those phone's hardware capabilities. Finally, you should optimize for input. I showed a few different input methods. With Continuum, users can interact with your apps that are running on Windows Mobile with touch, with a keyboard and mouse, with the Continuum controller, or even with the Xbox gamepad. And so, depending on what kind of app you're running, you should be considering which of those input methods actually apply to your application. So I'm going to take a deep dive into an example. This is a really simple photo albums application, and it was written in XAML with a C# code behind. And so we'll take a look at some responsive techniques for how you can build apps that actually reflow and adapt across screens really well. So I'm going to go ahead and switch over to the Surface Book, if the AV guys can help me out. Perfect. Great, so this photo albums app I have running on both a phone and a PC. Let me get reconfigured here. I have this running on both a phone and a PC, and I'll show you the code for some of the responsive techniques that were built into this app, and then I'll show you how those responsive techniques apply to this Surface Book, to my phone, and then to the big screen in Continuum, and prove to you, in a sense, that the work that you do to optimize for desktop automatically transfers to the phone on the big screen. So the easiest thing to think about for building adaptive apps is to just resize UI elements as the screen size changes. A picture shouldn't just become some small part of the screen whenever your screen is bigger. It should adapt and stretch to fit the full size of the screen. So let me pull up this app on here. So if you look at this application, there's basically 4 or 5 main components. At the top of the app, you can see this cover photo and the title. And a really simple thing to do is to actually have the cover photo change size as the app stretches and shrinks down on the desktop. And so you can see here that this stretching benefits you directly on the desktop. On the phone, I have the same application running. I deployed it earlier. And you can see that the photo here actually has stretched to fit the width of the phone specifically. So if we take a look at the code that was actually used to do that, it's extremely simple. This is, again, a XAML app. And here's the code for the cover photo. I literally have an image, and all I'm doing is saying, stretch this image uniformly across the screen, not setting any constraints to its width or height. It's just stretching naturally. And that will allow your app to stretch regardless of screen size or whatever image or property you have. You can also think about reflowing content. This means that on a larger screen, you might have multiple columns of content because you actually have the screen real estate to do that. Whereas on a phone, where a user is really optimizing for scrolling with their thumb, it's most likely better to have a single column of content that they can just scroll through quickly and fluidly. In the example app, we're going to look at the photo grid for this. So you can see on the desktop version of this application, as I shrink down the application, the photos actually reflow into a grid depending on how big the app is at any given time. And so that's done using a very simple grid structure that I'll show you in a minute. Whereas on the phone, the photos are all really optimized to be scrolled with my thumb one at a time. I can't actually put them into a grid because it wouldn't really be great for the user if they were small enough to be in a grid on the phone. So if we look at the code for this, all I'm doing is using a variable size wrap grid control and putting a bunch of photos in there. And you can feed photos in that are user chosen, et cetera. This is just a really simple example. And using a variable size wrap grid, will allow your photos to automatically reflow given screen size, regardless of how many photos there are or what size they are. The control will do the work to make sure that they reflow accordingly. There we go. You can also replace UI elements. In this example, whenever the screen is larger, the UI options, there's kind of 6 different items that you could click on. The 6 items on a large screen are really optimized for mouse and more of a pivot control, whereas when the screen size shrinks down, they're really optimized, again, to be tapped and opened with one finger, and they're also encapsulated in a hamburger menu instead of always being on screen. This allows you to really optimize for that UI when the user needs to switch between the 6 items, but hide that menu item whenever the user doesn't need to switch between them. So an example of that can be seen in the app again. When the app is running on the desktop, you can see that you can switch between different photo albums with this pivot at the top of the screen. And this pivot's always on screen, so the user can quickly and easily get to it with mouse. If I move over to the phone, you'll notice that I can't actually see the list of items immediately. I actually have to click the hamburger button, and then I can switch between the different photo albums. And that easily dismisses so that it can get out of the way so I can have the rest of the screen real estate for the content that matters to me, in this case, the photos. So the way I do this is actually by creating 2 different pages. One page is optimized for my touch layout, and one page is optimized for my mouse layout. And I'll show you how and when I activate those 2 different app pages. But on the touch layout, we use I'm using the split view control. This is our control that enables the hamburger menu to overlay on top of the rest of the app. And this is really easy to use. You essentially define a split view pane, which on the phone is the list of items. And then if you scroll down, I've defined content for the split view, which in this case is the album itself that has the cover photo, the title, the description, and all of the other photos in it. On the mouse layout, which was again the pivoted layout, I use a very simple pivot control with pivots, different item headers for each photo album. So I have one pivot item header for the layout I was showing, and then different item headers for each different album. It's also really easy to reposition content in order to really optimize for the size of the screen that your app is running on. So in this case, whenever you're on a small screen, again, as I said earlier, it's good to optimize for one-handed use, where the user will really only scroll vertically and probably not have anything side by side. Whereas on the big screen, you actually have the screen real estate to be able to show multiple components at the same time. So it's OK to shift, say, element B alongside element A in that case. So let's take a look at the photo app again. In every album, there is an album description. And on small screens, the description is kind of tagged at the top of the screen so that the user can read it and then scroll past it to focus on the photos. However, on the big screen, because there's, again, more screen real estate, it's repositioned to be always locked to the right side of the screen, so the user can read it anytime while they're enjoying the photos. And it doesn't really take away from being able to see the photos in any way because the screen's big enough. So again, on the desktop, you can see the description's locked to the right, and on the phone, you can see that the description's locked to the top. Let's take a look at how that works. So we are able to set these 2 different states with the Visual State Manager in XAML, and I have 2 different visual states using the minimum window width adaptive trigger. The first visual state is triggered whenever my screen is 720 effective pixels or greater. And whenever I'm in this state, I set a bunch of properties to basically position the grid of photos and the description. And I'm using the relative panel class here to do that. The relative panel class allows me to position UI elements and containers relative to each other and relative to the container that the app is running in. So for example, whenever the screen is above 720 effective pixels wide, I always position the photo grid to be aligned with the left of the panel, and I always have it below the title and the title background. However, in my second state, where I have an adaptive trigger with a minimum window width of at least 0, so this will get me in the state when I have a window between 0 and 720 effective pixels, I set the photo grid to be below the title, and I set the photo grid to be aligned with both sides of the screen. And then I set the, I set the photo grid to be below the description, directly below the description always, and then aligned to both sides of the screen so that it takes advantage of the full width of the screen. So if I take a look at the app on this display, you can see that, again, the description is here, but I want to show you that if I actually shrink the window size down far enough, below 720 effective pixels, the description will actually jump up to the top of the screen, just like it would on a phone. So that same logic applies on my desktop as it would on my phone. So the final example is re-architecting applications. And this is really a way for developers to really optimize and architect their apps differently depending on the device that it's running on. So in this case, the application has two different panes. It has a list of messages and a content pane that shows the content from those messages. Whenever the app's running on a phone, it doesn't make sense to show both of those things at the same time, so they actually create two pages and overlap them on one another. But on the big screen, they can lock those two panes side by side because there's enough screen space. So this isn't necessarily the best example, but one way you could think about this is, hey, on my phone in this app, I have two pages that I navigate between, and that's a totally different navigation and interaction model, as we showed before, than the pivot control that's on the big screen. And so this is one simple example of re-architecting, but there are definitely more ways that developers can optimize each screen. So I want to point out one API that I can use on Continuum to actually switch between the two different views that I was just showing, the phone view and what I call kind of the desktop view. So I'll go to the code behind my main page, and you'll see that I have two cases. And I'm basing two cases of what I show in my app off of an API called user interaction mode. User interaction mode has two returns. The first one is touch, the second is mouse. And these returns describe the type of operating system that your app is running in, or what kind of interaction that operating system is optimized for. So on the phone, this API will always return touch, because your app is running on a touch-first environment, and so should be optimized for touch. On the connected screen, or on a desktop machine, you will always get a return of mouse. That's because your app is running in an environment that's really optimized to be used with a mouse. And so for me, in this Photos app, I say, OK, whenever user interaction mode is mouse, I'm going to load my mouse layout, which I have built as a separate page. And whenever this API returns touch, I return my touch layout, which is, again, a separate page that I have. So I'm going to switch over to the dock and show you guys how this app actually scales and adapts on Continuum. Great. OK, so here I have the app running on my phone again. Same app. I never really closed it. I'm going to go ahead and launch it on the connected screen in Continuum. So now I'm showing the output of the display dock. And when I load this, all that's happening is the app is getting a window resize event. And you can see that a couple things have changed. One, I've switched over to seeing that pivot control at the top of the screen. That's more optimized for mouse input. Two, you can see that the description has snapped to the right side of the screen, just like it was on a desktop. And three, the photo grid has actually expanded to show more photos side by side. And all of this, remember, is work that I did to optimize for the desktop itself, and all of it just worked on Continuum. So this is kind of a proof of concept, a very simple example, showing how you can build an adaptive app that actually reflows exactly the same way on Continuum that it would running on a PC. Okay, so that's a good start to thinking about adaptive apps. There are plenty of resources for building adaptive universal apps. There's been plenty of sessions on it, and there's more resources online. So I encourage you to go investigate that more if you're building a universal app. The first thing that's really specific to Continuum that you need to think about as a developer is which device family you target. So you can target a couple of different device families. The first one, and probably the easiest one to target, is the universal device family. And this really means that you are building, as a developer, one app in one binary that runs across all Windows platforms: phone, tablet, PC, Xbox, etc. So if you do this, we are assuming that you're building an app that will run on a PC, and if you are doing that, your app should just work on Continuum, just like some of the apps I showed earlier. You shouldn't have to do anything special. However, I'm willing to bet some of you in this room are building mobile-only apps, and you've never thought about building for PC. You build maybe a mobile game or something that relies on GPS that you would only use on a phone. And that's fine. Mobile-only apps also work on Continuum. However, if you haven't thought about how your mobile app actually adapts and reflows to a big screen, you might not have a great experience on the big screen by default. You'll have whatever kind of adaptive triggers and adaptive layout you just get from whatever you've done on the phone. And sometimes that works, sometimes that doesn't work very well. It really depends on the application. So if you want to do a little work, you can use some of the adaptive principles I just showed to actually go ahead and improve your app so that it adapts a little bit better on different screen sizes. But if you find yourself doing a ton of work to optimize for Continuum, then I would suggest just going ahead and trying to build a universal Windows app, because that will benefit you not only on Continuum, but across all Windows device families. Your app can run on the desktop, it could run on the Xbox, it can run everywhere, and all of your hard work would pay off across all devices. So let's say that you've built an app and you have a phone app and you're not happy with how it works on Continuum. Well, it's really easy for you to opt out of being run on the second screen for as long as you deem necessary. And you do that by doing two things. You add a namespace to the package tag, as shown on the top, and then you set a true/false to the restriction value of restrict to internal screen. If restrict to internal screen is set to true, then your app will only ever run on the internal screen, which is the phone. And if it's set to false, then your app will run on every screen that a phone can connect to, which could be a monitor, TV, it could be any screen. And then if you're ready, so you can turn it on and off really easily in your manifest, and it should just update and run or not run. If you do disable your app on Continuum, it will appear in the user's start menu as a grayed out tile, and when they click it, they'll get a message that says, sorry, this app isn't available right now. We're trying to get more app support. So it's really easy to do that if you find that your app isn't ready, but we obviously would love if more apps are running than less. So those are really the two things that you have to do to be successful. The third thing that you probably should do if you want to have a really great and pixel-perfect app is think about adding scaling assets to your application. So every device has a different scale. And when I'm thinking about Continuum, I'm really thinking about three devices: a phone, a monitor, and a TV, because those are the most common devices people are using today with it. A phone typically has a scale of about 300. A monitor typically has a scale of 100, and a TV is typically 150. So each of these scales is basically a way for us to be able to ensure that with effective pixels and making sure that, a way for us to use effective pixels to ensure that UI looks the right size on every screen for the user. So when we're talking about adding scaling assets, we're really talking about adding new bitmap scaling assets. So let's say you have a bunch of icons in your apps that are actually bitmaps. And let's say that the user downloads your app. Whenever they download your app, by default, they will only get scale 300 bitmaps for that application. And that's because they're downloading it on a phone, and our resource management system tries to be smart and reduce footprint. So even if you've provided more scaling assets in your app package, they actually won't be downloaded by default when the user downloads them. They will just get the scale 300 assets. This means, so when they connect to a monitor, the monitor is going to want to be at scale 100. However, by default, they will actually have only scale 300 assets because the resource management, again, tries to be smart to not allow the phone footprint to explode if you have scaling assets for every scale that we support. However, if you do actually go ahead and have scaling assets for a scale 100 monitor in your app package, the resource management system is smart enough to be able to identify that you have those available in the store, and it will actually automatically trigger an app update whenever the user connects to this new monitor, and it will pull those assets down. The only kind of rough part of that is that the first time the user uses a new screen, they might not have the right scaling assets for that screen, but within 24 hours or 48 hours of connecting to it, they will actually get the right scaling assets. And so any app that's provided scale 100 assets in that case will then look pixel perfect on that display. And if the user actually doesn't ever connect to that display again for, say, 30 days or more, those scaling assets will be removed from the device to decrease the device footprint and ensure that we're not storing unnecessary assets for them. So the major problem that you'll run into with not providing the right assets is downscaling. And I say downscaling specifically because the phones today typically have a much higher resolution than any of the connected screens that people are connecting to. 4K screens are a thing, but not that many people actually use them. So the most common scenarios is going to be somebody connecting a 300 or 400 scale phone down to a 100 scale monitor. And when they do this, the assets will be compressed down to a scale 100 if you have not provided scale 100 assets. And if they're compressed, they will look a little bit blurry. Now, you probably can't actually see how blurry these are because in reality, with downscaling, assets aren't quite as blurry they aren't usually blurry enough to make a big difference. So that's why I'm not saying this is something that you absolutely have to do to be successful in Continuum. This is really something you should think about if you want your app to be pixel perfect on every display a user can connect to, and every Windows PC on the market if you have a universal app. Now, as we go into this world of 4K displays, we might run into problems with upscaling, where the phone might have a lower resolution than the connected screen. And when you do this, let's say you scale 100 assets up to a scale 400, we actually would have to stretch the assets, and that can result in the assets being much blurrier than if they were downscaled. So as we get into this world again, where we have more and more 4K or higher displays on the market, this will become more of an issue, and it would be up to you as developers to make sure that you're providing assets to make your apps pixel perfect in these cases. So let's talk about how you actually reference these scaling assets in your app. It's really easy to do, and because of the resource management system, you don't actually have to do that much to make sure that the right assets wind up on the right screens. So here I have an app solution, and one way that I can add scale-specific resources is with a .scale-xxx notation. So in my app solution, I have my assets folder. And each asset that I have, these are all bitmaps, I have 4 of each different kind. So for my logo, I have a logo.scale-100, logo.scale-150, etc. And all of these were individually designed for each of those scale factors in the designer. The other way I can put them in my solution is in scale-specific folders. So instead of using the .scale-xxx notation, I can include different scaled assets in scale-xxx folders. So I can have a scale 100 folder, scale 150, etc. And in each of these folders, I can put exactly the same list of images so that I have all of them available for every different scale that I support. And then it's really easy for me to reference these resources with a URI. And the great thing about the resource management system in Windows is that you don't have to have any responsibility for making sure that the right assets wind up on the right screen. All you have to do as a developer is reference the asset that you want with a URI without the scale.xxx notation. And if you've used the foldering systems that I showed, then the resource management system will do the right thing to grab the right assets at the right time. and put the best optimized assets that you have on each screen. So even if you only have a scale 100 and a scale 400 asset, and your user is using your app on a scale 150 screen, the resource management system will be smart enough to grab the scale 100 asset in that case. So I encourage you to include assets in this way so that you can have pixel-perfect apps on every screen. Great, so the final thing I want to show is something that I love, and that is your ability as developers to build multi-screen experiences. I showed you PowerPoint earlier. They have a great multi-screen experience for presenting, but there are other apps that do this. And there's two main APIs that you can leverage to build these multi-screen experiences. First is the Cast API. The Cast API allows you to take a media element. This is really best for media developers. Take a media element, hand it over to Windows, and say, hey, put this media element on the second screen. And the code to do this is really simple. So the first thing you do is create a casting picker. This basically means that you're creating a piece of UI that the user can use to select the device they want to send the video to. You filter it to only videos if you have a video and you want to send a video to the external screen. You add an event listener and find all of the video devices around you. You show the selection UX when you've found all the video devices around you so that the user can actually go ahead and choose one of those videos. And then finally, you get the selected device from the user, and you send the media element to that screen and begin casting. So this API is great if you just want to enable the very simple scenario of putting a media element on the screen. The limitation of this API is that once you move the media element over there, you as a developer don't actually have control over that media element. And that's why we have the Projection Manager API. This API actually gives you full fidelity control over a view that's on the phone and a view running on the connected screen. And PowerPoint actually leverages this today. That was the experience I showed you. And so you can actually have full control of the two screens and how they interact with each other. And this allows you to create much more robust multi-screen experiences for any purpose, whether it be media, productivity. You could imagine gaming apps that have a gaming controller and a game on the big screen. The options with this API are really limitless. So let's take a look at how you might implement this. You start by checking whether or not there's an active connection. If there's not an active connection, you would use kind of the same protocol that I showed for casting to hunt for a device, have the user pick one, and then select a device. But if there is a device connected already, like in my case, you can create a new page to display in the view that's going to be shown on the external screen. So this is the point where you're actually creating the view for the connected display. You actually show the view on the second display when you call start projection async. And then whenever you're ready to stop projecting, or the user invokes a button to stop projecting, you call stop projection async, and the projection session ends. So again, this is a really simple API to use. All you have to do is create the two views, one for each screen that you want to show. So I actually have a great example of an app that's leveraged the Projection Manager API. And I will go ahead and show it to you. So here again, you're seeing the output of my phone and the output of the Continuum dock. And I'm going to open an app called Sohu. And Sohu is a very popular video app in China. And I will select just the title video. You'll see here that I have the video playing on this screen. And there's a casting button right here. And so when I press this, it actually brings up a Connect UI, it brings up a picker that will allow me to see all of the video endpoints that I can show the video on. And I'm already connected to this generic PNP monitor, so I'll select that. Oh no, sorry guys, round two, we'll try again. There we go. So here you go. So this time it worked. They actually have used the Projection Manager here to put the video on the second screen. And because they use Projection Manager, they are able to build custom controls to pause the projection, fast forward between the video, or scan different parts of the video. and interact with the videos in ways that they couldn't do if you had used the Cast API, but both are great for different purposes. So I'll stop projection of that, but that's a really great implementation of the Projection Manager API. Okay, so those are all of the tools at a high level that are available for you today to really be successful on Continuum. There are deep dives on all of these things online on MSDN, so I encourage you to take a look. But the main call to action is really, for you guys, is to build a universal Windows app. Again, if you do this and you build views that are optimized for desktop and mobile, your app should just work. And then if you do that, you can also consider additional things like adding scaling assets and building multi-screen experiences to really highlight your app across screens. Thank you guys so much. I have 2 Windows gift cards who I will give to the 2 people who come up and tell me what they think the coolest use of Continuum will be in the future. So thank you guys so much. Happy Friday.